we're looking at a project folder for a Pavlov 3D project, and I'm going to show you 3 different versions of the software, and you can see the different weights. So this light version has no preview capability. This new one, CLI, I'll go and change the name to that. I just gave it the default name. We'll call it CLI.spark. That is very slightly, like 7 kilobytes larger than light. And it has preview functionality via Sparklines, and I'll show you what that means. And here's a preview with a matplotlib, and it is much larger. So just a quick walk around a project folder for Pavlov. So you have your imports. So hey, there is a file we want to look at, and I'll go ahead and grab another one just for rigor from another project. This is my development directory, and I know this is here because I've been using it. Alright, great. So that's another raw data file. Let's go ahead and look at that. Okay, CSV, list of numbers, time, value. The other one, time, value. So they're different in terms of the ranges and the organization, but based on our rules, which we're following in our user input config. So this is the set of rules we're following. Time is our column header, value. So it's going to look for those text flags, and then it's going to follow these plugin rules from the code, and it's going to group things into these group names. There's some other things going on here. It knows to follow that set of rules based on what's in this config entry point. So that's the name of the JSON file, and then it'll run based on those rules, and then it'll give us an export here. So that's the basic idea to generate an FBX file. Now let me show you the heavy version. Takes a long time to open, kind of annoying. Great. So this is just a quick and dirty way to import all the data, 1, 2, 3, 4, 5. And I could say 6 to make an export, but let's say that I want to preview. Great, and so totally different scales. We can see that other file is a little guy. But this whole experience is like not that pleasant in my opinion. Like, are we really getting an idea of what the data says? I don't feel like I am. Especially if there was like more going on here. Matplotlib is fine. I don't know, this could be okay. But that's what you get for all that extra space, like twice the size of the program. Now for the Spark version. It's not twice the size, excuse me. An additional 50%. Okay, same rules. Import the data. So this is just saying what data is in the import file, follow some rules. So just a quick description of what's happening. Make scene, that's just preparing the basic scene variables. Make config, that's saying import the stuff from that config file. Skip interface, that's saying go ahead and set the values we have with no expectation of them being altered. So this is where you would like open everything in a GUI. So if you open a GUI version, it'll automatically populate with whatever config file is being pointed to, and of course it'll just make the underlying scene file and whatnot, and then you'll be ready to edit from there. And when you hit submit, you're like, okay, those are my, that's what I'm using in terms of my configuration. So skip interface says set the configuration, we know what we're doing. Import data says, hey, go to those data files that have been pointed toward, pull them in, make the point cloud. So this kind of moves everything around. It does some translation. Pavlov is a very point cloud oriented exporter, and then actually export the file. So we want to be able to preview. So we've done everything. Let me check status. Great. True. We've done all those things. We have all these things. We have a point cloud. Great. So now, Spark. Let's say I want to see the height values for all two of my files. There you go. I can open this up because it's going to need it. Height all. Didn't I say that? Okay, well, something's wrong, and I will pay for it and fix it in a second. Index 1. Cool, okay, great. So these are the height and time values. So time is kind of dumb, like we know what time looks like, but it does give us some summary stat. And the height values, we can see the rise and the fall. It's not all on the same line. It is stuck with like what is a cursor. Every data point gets its own cursor spot. So this thing goes on, not ad infinitum, but for a long time. And so we can see these sparklines. Let me go back to the code really quickly. What's wrong here? Height all. Yes. For I in enumerate array. Good. Something is broken. Great. Once we take this text change, is that the same? Why or why not? It looks the same to me. Screw it. Let's get rid of the old one. Yeah, so if height, oh, yeah, good. I know this is like not the way you're supposed to do this. Spark, oh, doy. Great, okay, so now we can see the difference in what is the height for this one. We'll call that file index 1. I don't know if that's a good practice. Let's just change that. That's dumb. If people know what I means, people know what in means. Boop. If we're going to call it I in the code, may as well call it I not in the code. How about that? How about those apples? No, because it's not necessarily a file. Alright, so we can see that, hey, this, this data sure does vary. This data seems real smooth. Okay. Who cares? You can't really see the peaks in this data. But, this isn't necessarily the very best way to look at it. It just gives you a way to look at it without it costing you anything. This is the version without Spark. So to be able to see this costs you 7 kilobytes, and I don't care. Don't use it if you don't like it, but it's in there. I think it's hilarious. Speaking of hilarious. What do you expect it to look like? It's time. Of course it's going up. 50 seconds to 60 seconds. So it's set to its minimum, like, is the little guy. That's how I have it done. I have it, put a line in here. Yeah, looks like this. So this is some list comprehension saying, subtract your minimum, assuming you have, well, you don't need a negative value, but just scale everything such that you don't have negative values. That's all that is. Because you can't look at negative values in this, and it'll tell you if you have a negative value. Let's see. Where's this minimum negative 27? If this is negative 0, and this is 9, just whatever the thinnest thing is going to be negative 27, so it's probably like right there. So like again, not great, but it works better than not having it, I guess. Fun. Sparklines. Pavlov. Go. Am I making the greatest data analysis program of all time? No, I'm not. This is for troubleshooting on your way to generating. All right, just bread and butter real quick for the kids. Pavlov. Let's look at the small one. I don't love that one. Let's look at a different one. Let's look at this one. Just a quick overview of what we're making to understand where all this is headed if you don't know. It's okay if you don't know. Welcome to my video. This is the Pavlov 3D software project. Pavlov Software and Services LLC. You have stumbled upon the wrong room, sir. This is an FBX file. We're looking at it in CAD Assistant. You can learn about all that in the instructions. To open FBX models generated by Pavlov 3D as they are intended, download and install CAD Assistant. Boop, 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 boop. It's great. We love it. The purpose being, look at your dank models. You can see everything all at once. I love it. Okay, so this is two-direction redundant. So what's happening here in what I would refer to as the depth direction, it is very obvious that these curves that we can see looking down are redundant of the curves that we can see looking forward. It's just to make it a little easier. So we've got two styles here. We've technically got two models. We have a bin gradient model. Oop, looks like that. And then we've got a color per curve model. Looks like that. Fantastic. This is an FBX file. Look how wonderful it is. This is the Alturas group. Those are all of the different files that belong to the group Alturas, as you can see from their file name. Wow, love it. These are subgroups, SWS101, SWS204, and within them are the individual curves. And so now we can get an idea of how stuff's organized. And we could say, oh, that's interesting. It sure seems like SWS409 is consistently a higher performer than SWS104. Which is a higher performer in general, Alturas or Seahawk? I can't rightly tell. We have some text scaling issues. Like, I need to be able to read these to better discern the narrative between them. There's problems here. We're trying to solve our problems. We're getting places. But I love it. Okay, so the whole idea is you're trying to generate this type of file. I'm trying to provide you with the software that will do that. And as you go through the course of doing that, you need to be able to do some troubleshooting, in my opinion. Because, like, it doesn't make a ton of sense all the time. Does it? No, it doesn't. It's kind of hard. We're making software. It's kind of hard. See? See what's happening to me? Make it stop. Eval. Scene. Object. And yeah, this is trash. So that made a fresh one. There. Doesn't have anything in it. Anyways, why? What? Who? How? When? Units to time. Ooh, we should change that. Copy. Paste. Great. Pavlov 3D, check it out. You go to our website. That's the other thing. It's like, how do you help people make these? And let's say they have other data. It might look like this. You know? To make complex models quickly, that's the point. That's what we're doing here. You have a bunch of data. I want you to see it all at once, right now, in a way that makes sense and is useful. That is a tall freaking order. You know? But rather than make you something heavy like MATLAB, or, you know, you having to learn pandas to organize your data to see your stuff, I don't want you to learn anything. I want you to come in here and I want you to say, main, open it up, drop your files in the right place, make sure all the rules make sense, and it'll spit out an FBX file for you. And then you can look at it and you can say, oh, hey, that's weird. What's happening there? Hey, what's the maximum value? Oh, it looks like it's, oh. You know, whatever narrative this means to you, I'm trying to help you get there. Is this, I don't, you know, tell me what you think. How about that? I've done enough of what I think. Tell me what you think. This is also persistent. This is a file. That's the difference. I'm done now. I'm walking away. Do you like my Sparklines? Do you like my Sparklines? Tell me you like my Sparklines. Here, watch this. Right, okay. Max 77745. Okay, that's double. Why is it double? Because of some of the rules. So this is redundant. As you can see, these two files and these two files, they look the same because height and depth are redundant like this. Height and depth are redundant in the color per curve model. They are not redundant in the bin gradient model. Depth is consistent to a single point size. That's homogeneous for all curves in the bin gradient model. But it's not perfectly a 1-to-1 ratio. Look at this. See that slope? Why is that? That means that depth is going to be half of height every time. That's how it's calculated. It's calculated automatically that way. And that looks like this. They're the same, except the depth values are half of the height values. Whoa! Sparklines. What do you think? You tell me.